2006 Canadian Open Mathematics Challenge, Part A. What is the value of? It's a basic question. Just add up these. This is 3 over 2, and then you're multiplying by 4 over 3. This is 5 over 4, and the last one is 6 over 5. And I hope you will see that this cancels with that 4 cancels with that, and that 5 cancels with that 5. So the only thing you're left with really is 6 over 2, which is 3. That's the answer. If f at 2x plus 1 is equal to x minus 12 times x plus 13, what is the value of f at 31? F at 2x plus 1 is x minus 12 and x plus 13, the product of those two. So let's see what we can get. We want 31 to be here. So that means that we want 2x plus 1 to be 31, right? So let's solve that. That means 2x is 30, x is 15. So this becomes f at 31 since x is 15. And then I substitute x equals 15 over on this side. So it'll be 15 minus 12 and 15 plus 13. So 15 minus 12 is 3. 15 plus 13 is 28. And 3 times 28 is 84. In triangle ABCM is the midpoint of BC as shown. If triangle ABM is 15 and angle AMC is 30, what is the size of angle BCA? So this is what we call angle chasing. It's one of the more simpler angle chasing questions. There's far more complicated ones. So let's go through this. ABM, where's that? ABM is right here. So that's 15. That's what they told me in the question. And they gave me another one, right? AMC. So that's this one, and that's 30. Okay. All right, so where do I go from here? Let's see here. Okay, well, all the angles about that line are equal to 180. So to get this one, this angle right here, which is BMA, I would just subtract 180. It would be 180 minus 30. So this angle in here is 150. And then therefore, since all the angles of a triangle add up to 180, and this is a triangle, I can easily get this, and it will be 180 minus 150 minus 15. So that is 15. So there you go. This is 15. So this is 15 and that is 15. So that means that that is an isosceles triangle. This side is the same as this side. So we'll just put a little mark there like that. That basically means that this side is the same as that side, and we concluded that because these two angles are the same. Okay, well, interestingly, that means that this is now an isosceles triangle because those two sides are the same. They're the same length. And if that is the case, then these two angles are the same, this one and this one. And I'll just call it theta and theta, and then we can just solve. So theta plus 30 is 180. That's the property, of course. And therefore, 2 theta is 150, and theta is 75. And that is BCA. BCA is this angle right here. So therefore, angle BCA is 75 degrees. Determine all solutions xy to the system of equations. Okay, so I've only been given 2. So let's see. And there's 2 variables, so it shouldn't be too bad. I'll call that equation 1. I'll call that equation 2. All right, so we got to manipulate them in whatever way you feel is appropriate. And, you know, there's lots of directions to go in. I'm going to try to eliminate the x's, and I think I can do that by taking equation 1 and multiplying it by 3, and then subtracting from that equation 2 multiplied by 4. And I think that should get rid of the x's. So let's see what happens here. Then we get 12 over x plus 15 over y squared. And then that'll be subtracting 4 times equation 2. So 12 over x plus 28 over y squared. And on the other side, it would be 3 times 12, which is 36, minus 4 times 22, which is 88. Okay. And as expected, as planned, the x's disappeared, right? 12 over x minus 12 over x. And that's what I want. So what I'm left with is 15 minus 28 over y squared. And on the other side is minus 52. So if I put the y squared on this side, it'll be minus 13 over minus 52. And that is 1/4. So therefore, if I take the square root now, it's a half, plus or minus. Okay. And I guess now I just have to substitute this back into either one of these to get the value of x. Okay, so let's do that. Either one, I'll just put it in this one. It's not a problem. So 4 over x plus 5 over y squared. Y squared is 1/4, according to that. So that's 1/4 right here, and that's 12. So that means this is 4 over x. What is that? 20 plus 20 is 12. So 4 over x is equal to minus 8. X is therefore equal to minus a half. So therefore, my solutions are xy minus a half, and minus a half, negative a half. So those are my two solutions to this system of equations. In triangle ABC, BC is 4, AB is x, and AC is x plus 2. If the cos of angle BAC is x plus 8 over 2x plus 4, determine all possible values of x. Let's draw a very basic diagram. I have no idea what this triangle looks like in terms of its sides, in terms of the lengths of the sides. So I'll just draw a basic one. This is A, this is B, and this is C. So they tell me that BC is 4, okay. AB is x, and AC is x plus 2. And then they tell me that the cos of angle BAC is this. So where's BAC? BAC. I'll just call that theta. So that means that the cos of theta is x plus 8 over 2x plus 4. Okay, so that's what they've given me in the question. So this screams cosine law. Those of you that are familiar with the cosine law probably knew that this question is going to utilize the cosine law as soon as you read the question. It's so obvious. So cosine law applied to this triangle would be the following. BC squared is equal to AB squared plus AC squared minus 2 times AB times AC cos theta. And I think we have everything, at least in terms of x. And then, of course, it's going to be some quadratic, most likely, because there's all these squares here. Okay, let's fill it in. BC is 4, so 4 squared. AB is x squared. AC is x plus 2. That's going to be squared. Minus 2ABx. AC x plus 2. And then cos theta x plus 8 over 2x plus 4. Okay, done deal. So let's do this now. 16x squared plus expanding x squared plus 4x plus 4. I think this will cancel before I expand this and make it messy. This 2x plus 4 is going to cancel with this 2 and this x plus 2, because this, if you multiplied it, would be 2x plus 4. Okay, that's good. That's a little bit less messier. So the only thing we're left with is just this x and that x plus 8. So let's just expand that. So it'll be minus x squared plus 8x, like that. Okay, let's put everything on one side. We've got 2x squared minus x squared, so we're going to have just x squared. Then we're going to have 4x minus 8x. Don't get confused there. So that's minus 4x. And then there's going to be 4, and then bringing the 16 over, be 4 minus 16, which is minus 12, equals 0. And this factors very nicely. X, 6, 2, negative, positive. So x is 6 or minus 2. But please be careful here. Don't just leave it. Can you tell me why you shouldn't just leave the answer like that and move on? Because x represents a distance, right? For example, it's AB. So because x represents a distance, it cannot be negative. So therefore, x equals 6, since x is a distance. And therefore, x cannot be negative 2. Can't have negative 2 inches. So there you go. X equals 6 is the only valid solution to this question. Determine the number of integers n that satisfy all three of the conditions below. Each digit of n is either 1 or 0, n is divisible by 6, and n is between 0 and 10 to the power of 7. All right, so we've got some number that has only 1s and 0s. That's what that's telling me. So for example, something like 1, 1, 0, 1, 1. That would be an example, right? I'm just kind of giving you what it could look like. N is divisible by 6. So then this number, if you divide it by 6, would have to be an integer, some integer k. So that involves a divisibility rule. Divisibility rule. And there's many of them. So this one obviously is involving 6. And if a number is divisible by 6, there's two things you can conclude. The one thing you can conclude is the last digit of that number has to be even. And the sum of the digits has to be a multiple of 3. So I'll give you an example. All right, let's think of an example here. Okay, so let's say I gave you this number 1, 1, 1, 1, 1, 1, 0. And I said, without using a calculator, just using these divisibility rules, tell me, is this number divisible by 6? Okay, well, it shouldn't be that hard, right? With the divisibility rules. The last digit is even. Is the last digit even? Yeah, 0 is even. And the second rule, sum of the digits is a multiple of 3. Okay, let's see. Well, we have 1, 1, 1, 1, 1, 1, 0. The sum of the digits is 6. Is 6 a multiple of 3? Sure it is. It's 3 times 2. So this number is divisible by 6. And I could tell you that relatively quickly without the use of a calculator. So that's what we're going to use. And the last one, that just tells me that this n is between 0 and, what's 10 to the power of 7? 10 million? 2, 3, 4, 5, 6. Yeah, I should know that, right? Okay, so there you go. That's just a boundary they're giving us. Good, and that's good because that means we don't have to go on forever. Okay. I guess in these kinds of questions, we'll just make a table and just off we go. So number of digits of n, and then we'll give an example, and then we'll write out the ones that fit our criteria. And I think we can do this manually because I don't think there'll be that many cases. And then the total number of cases, and then off we go. And I think that should be sufficient. Okay. All right. So here we go. Let's see what happens. First, we'll start off with one digit, like it's a simple digit, simple number, and there's only 0 and 1. So for our criteria, which is these 3 criteria, I don't think we have anything that fits because we only have 2 choices, 0 or 1. 0 it can't be because then it has to be greater than 0. And it can't be 1 because 1 is not divisible by 6, correct? So none. So 0 here. Just put 0. Okay. It'll probably be a little bit more interesting as we go on. That one was not very interesting. Okay, let's do 2 digits. Let's move this up a bit. Okay. 2 digits. So, for example, a number like 10. That's a 2-digit number that it utilizes only 1 and a 0. Now, our criteria, we want the final digit to be even. So that means there's only 4 choices, right? 0, 1, 0, 1, 1, 0, 1, and 0, 0. And 0, 0 technically is not really even a choice because there's no such number 0, 0, right? You would never write that. You would just write 0. And now of these 4, I don't think any of them fits our criteria because, first of all, the last digit has to be even. So the only numbers that we are ever going to use end in a 0. So this one and this one. This one we already eliminated. And 10 is not divisible by 6. So none. So again, we have none so far. I think we'll get some sooner or later. Let's try 3. 3 digits. Again, it's not a very, there's not that many, so I'll just write them out. 0, 0, 0, 0, 0, 1. The 1 there and the 1 here. And then 1, 1, 0, 1, 0, 1, 0, 1, 1, and 1, 1, 1. Okay. Now, again, if you go through this, none of these satisfy the criteria. Now, the good news is you won't have to write them all out, right? Because I know you think, geez, once I get to 4 or 5, it's going to be crazy to write them all out. But there's a shortcut. With 4 digits, let's just go straight to the criteria. I'm not going to list them all. The criteria says that the last digit has to be even. Okay, so the 4-digit number, these are the 4 digits. The last digit has to be a 0. Okay, that's great. And then these ones, the sum of those, the sum of all of them really, but the 0 doesn't add to the sum. The sum has to be a multiple of 3. Okay, the only way to do that is to have 1, 1, 1. Any other combination would not be a multiple of 3. So there you go. In a quick way, I've been able to figure out an example of a 4-digit number that satisfies all these criteria. It uses only 1 and 0. It is divisible by 6 because we satisfied our rules. And it's between, 0 and 10 million. Okay, so we got 1. And that's the strategy that we have to use. So let's just keep going here. Let's just move it up. I think by now we should be able to sort of know the criteria well enough that we can just do it. 5, 6, 7, and I think that's 8. That's it. Because once you get to 8, you will exceed the range, which is 10 to the power of 7. Because the 10 to the power of 7 is what? 1, 2, 3, 4, 5, 6, 7, 8. And any number that's greater than that will not be allowed because it's outside the range. And 10 million itself is not divisible by 6 because of our divisibility rules. The sum of the digits here is 1. And 1 is not divisible by 6. So our criteria, none and 0. So these are the only ones that are going to be possible. So let's see what happens. With 5 digits, let's go straight to the criteria here. Let's not, mess around. 5, 1, 2, 3, 4, 5, like that. So our divisibility rule says last digit has to be 0. Okay. And then the sum of the digits has to be divisible by 3. So we've got to put 3 1s in there. And this is one way of doing it. Another way of doing it is 0 here, 1, 1, 1. And then the other way is, of course, putting the 0 there. We can't put a 0 in the front because that would no longer be a 5-digit number. And these are the only 3 that I can get to fulfill my criteria. Let's go to 6. 6 digits this time. And we've got 1, 2, 3, 4, 5, 6. Same thing. It's got to be a 0 at the end. And then we got to put 3 1s in there. But the lead off has to be a 1. So that basically means in these 4 spots, we have to put 2 1s. So here's one example. Correct? So really, it's a choose notation now. From those 4 spots, you have to choose 2 spots to place the 1. And that's basically the number. That's how you would calculate it. And 4 choose 2 is equal to 6. So there you go. So like I promised, there will be a shortcut. 8 we already did was 0, right? Because of the boundaries, n cannot be greater than 10 million. So now we're just down to 7. Same thing, 1, 2, 3, 4, 5, 6, 7. The last digit must be a 0 because of our divisibility rule, and the leadoff has to be a 1 because if it's a 0, it would not be a 7-digit number. And then we have now 1, 2, 3, 4, 4, 5 spots, and in those 5 spots, we have to choose 2 spots to place the 1. So for example, if we chose this spot and that spot, then the other spots would be zeros. So if I choose 2 is basically the calculation, that's 10. That's 10. But here's the thing. The question's a little, I think this is probably the hardest part of the question, that there's also a scenario where you can have, well, it's 7 digits, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. That has to be a 0. There's also a scenario where all of this remaining 6 can be 1s. 1, 1, 1, 1, 1, 1, because the sum of the digits then is 6, and 6 is a multiple of 3. So in addition to these 10, you've got another one here, so the total here is 11. Okay, let's add it all up finally. 1 plus 3 is 4, 4 plus 6 is 10, 6 plus 10, 6 plus 11 is 21. So I hope that made sense. It's a good question. I encourage you to learn it because these types of questions actually occur quite a bit on math contests. So suppose n and d are integers with n positive and d between 0 and 9 inclusive. Determine n if n over 810 is equal to 0.9d5 repeat. And they've given you what it means. 95, 95, goes on forever. Okay, I have seen these kinds of questions before, and it's actually pretty cool how it's solved. So here we go. So the first thing they gave me is that n over 810 is equal to this 9d5 repeat. And they've told me that it's, you know, obviously 9d5, 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 and it just keeps on going, dot, dot, dot. Okay, great. Now what I'm going to do is I'm going to try to subtract something from this so I can get rid of this repeat part. And this is how you do that. In order to get one of these before the decimal point, I'd have to multiply by 1,000 since there's 3 of them. So I multiply by 1,000 to n over 810. Right? So like that. And that makes it nd5 dot 9d5, 9d5, and so on, like that, right? Now what you do is you subtract these. So it'd be 2 minus 1. And 2 minus 1, it will be as follows. It will be 1,000 n over 810 minus n over 810. And this is where this whole decimal, this whole repeating decimal disappears. Notice when you subtract 1 from 2, all you're left with is just 9d5. And that's the key to these kinds of questions. And that's this process involved in getting rid of all those numbers after the decimal point. And now at this point, it's fairly workable because they've already given you a range for D. This will become 999n over 810, and this is 9d5. Okay. Let's see here. Now we have to expand this, and I just want to do it on the side. Let's say you have a number that's 945. 945 is not 9 plus 4 plus 5, obviously. What it is 9 times 100 plus 4 times 10 plus 5, correct? So by the same sort of philosophy, we're going to do that here. So it's 900 plus a d times 10, which is 10d, plus 5. That's what 9d5 would be if you expanded it. And this part, I think we can reduce this. If you divide by 9, I think it'll be 111n over 90. Yeah. Okay. What is our goal here? Determine n. Okay. And then d is between 0 and 9. All right, so no problem. Okay, let's keep going here. I guess 111n is equal to 81000 plus 900d plus 450. Okay, so we got two variables but only one equation, so that means we have to do this manually. And the good news is that they've given us a range for d. So we have d, and then we'll have some number that is there. And then we will have to divide by 111, so the number divided by 111 to figure out the value of n. And n has to be an integer, I believe. Let me just go back and double check. Yeah, n and d are integers with n positive. Okay, so n has to be a positive integer. All right, no problem. Hopefully we won't have to go too long. Remember, d is between 0 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The fact that you can't use a calculator just makes this a little bit more of a headache, but you know, it's not that bad. Okay, when when d is 0, it's 81450, and when you divide this number by 111, you get n, and it's not an integer. It's like 733.7, and you know, they just want you to do a little bit of manual calculation because the calculator is not allowed. All right, no problem. When d is 1, we get 82350. When you divide it by 111 to get n, you get 741.8 approximately. So it's not an integer. How about 2? It becomes 83250, and that is going to be 750. So there you go. You got your integer. So that means when d is equal to 2, n is equal to 750. What is the probability that 2 or more successive heads will occur at least once in 10 tosses of a fair coin? So, like all probability questions, it will be some fraction, something over something. Now, the denominator, the number that goes here, is a total number of cases. So if we're tossing the coin 10 times, each time you have either head or tail as a possibility. So each toss has 2 outcomes, either heads or tails. So if you're tossing it 10 times, then you have 2 to the power of 10 possible outcomes. So that's the total. And then what goes in the numerator, of course, is what we have to figure out. That's our specific condition. But in this question, it's easier to do the following. This is my probability, but I want to actually figure out the probability that there's no successive heads. If there's no successive heads, then I can subtract that from 1, and it will give me this probability, which is what they have defined as at least 1 successive head. So I want to figure out the probability of no successive heads. And then I'll subtract it from 1, and that will give me my answer to this question. So whatever it is, something over 1024, which is 2 to the power of 10. Okay, here we go. So let's say it's all tails. If it's all tails, right, there's obviously going to be no successive heads. So all tails is basically, you know, where all 10 tosses turn out to be tails. And how many ways are there to do that? There's only one way. So number of ways, there's only one. Okay, that's straightforward. Now what if you have 9 tails and 1 head? So an example is, say, tail, 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 and then you have your head, and then tail, and then the remaining of tails. This is one example of 9 tails and 1 head. Here is also a criteria. It fits the criteria of no successive heads. How many ways are there to do this? Well, you can use choose notation. From these 10 spots, you have to choose 1 to be the head. And 10 choose 1 is 10. So there's 10 cases there. All right. So that's a way of doing the 9, 10, and 1 head. Now we get to 8 tails and 2 heads. 8 tails and 2 heads. So for example, something like this: tail, tail, head, tail, 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 head, tail. Now this is 2 heads and 8 tails, but it also fits the criteria that there's no successive heads, right? Because the heads are not one after another. Now our task is to figure out how many of these are there. So let's move this up a bit. So here is the explanation of how you would figure this out. If a sequence of length 10 consists of 2 heads and 8 tails, as I have written here, then we start with this kind of scenario and realize that you have to put the heads away from each other. At least one tail would have to be between them, because we can't have any successive ones. You can't have any, the heads cannot be side by side. Each of those 2 heads must be placed in separate spaces. We can then eliminate any unused spaces to obtain a sequence of 8 tails and 2 heads containing no consecutive h's. And we get all such sequences that way. So there are 9 choose 2, which equals 36 ways of positioning the heads. And so 36 such sequences. So this scenario gives me 36. And then similarly, if you have 7 tails and 3 heads, you would use the same methodology, which in this case would be 8 choose 3, and that is 56. And if there's 6 tails and 4 heads, then you would use 7 choose 4, and that's 35. And then 5 tails and 5 heads would be 6 choose 5, which is 6. Now, and once you get down to 4 tails and 6 heads, it's not going to work. It's going to be impossible, because it would be 5 choose 6, and you cannot choose 6 from 5, right? There's no such thing. And also, once you get down to 4 tails and 6 heads, it's impossible to have no successive heads. You wouldn't be able to do it. No matter what scenario you tried, you'd always have at least one successive head. So this would be, basically 0 cases. So the only cases you really need to worry about are these ones right here. So 1 plus 10 plus 36 plus 56 plus 35 plus 6. So you have 144. 144 out of the total, which you remember was 1024. And that is what we have to place here. So this basically becomes 1 minus 144 over 1024. And this is 880 over 1024. And in lowest terms is 55 over 64. And there you have it.